insert this lancet into the eyeball and cut cornea from sclera, okay? And I'll help you. It is with a power because it is hard tissue. It is necessary to insert. Yes. Please cut it. I want just a moment. Please. Okay, it's too thick coat cornea, and heat is iris with pupil. That is eyeball of the cow. That is why it is oval in shape, oval pupil. And now I remove iris, and you can see what is it? That is a lens. That is a lens, and behind of lens, vitreous body. You can see that vitreous bodies look like gel, yes? That is vitreous body, and that is lens. This lens is not transparent because this eyeball was in formalin for a long time. But if we remove some layers, it looks like onion. You can see that inside it is transparent. It is transparent, and also it's too hard, but in living man it should be soft tissue, soft lens, but this one is hard. Can you take it, please? And now we continue to cut. We cut it into two halves, into right and left half. Please.
From here?
Yes. Oh, from this place.
So
yes, yes, everything. Not cut your fingers, please. And mine the same. Okay, this white color, that is white structure, that is retina, and very easy to remove retina from hyoid tissue. Only one place where retina is fixed, that is optic disc, beginning of optic nerve. Okay, that is optic nerve, and this place of retina is fixed. In all another places, very easy to remove retina. The same, not so difficult to remove hyoid from sclera, because we have space between hyoid and sclera. Yes, that is perihyoid space. Spatium perihyoidale, perihyoid space. Spatium perihyoidale. Well, and only optic disc is we can see it after we remove hyoid, retina. We continues to see optic disc because it is place where optic nerve pass. Well, that is internal structure. Move it. It is, and now in this model. In time of final exam, you will answer eyeball in this model. What is it? Cornea. Heat is sclera, and this place where cornea joint with sclera, that is no. That is sulcus sclera. Yes, conjunctiva, it's come to eyeball from eyelids to eyeballs we have conjunctiva, but it is absent. Now I remove cornea, this angle between cornea and iris, that is iridocorneal angle or angle of eyeball, angulus bulbi. Then it is lens, that is vitreous body, this orange color, that is retina, and it is choroidea, and choroidea continues into iris with pupil. This one, this white color, that is disc of the optic nerve, and you can see that ophthalmic artery, it gives arteria centralis retina, and this central artery of retina together with optic nerve goes to retina and supplies it with blood. And yellow spot, that is fovea centralis, that is point of the best vision. What else? Accessory organs. Next time you will answer accessory organs of eye and visual analyzer. Which accessory organs do you know in eye? First of all, that is muscles, and you already know names of these muscles. They are musculus rectus superior, inferior, lateralis and medialis. It is musculus obliquus superior and musculus obliquus inferior. They are striated muscles, and they are accessory organs. Outside, between orbita and eyeball, the same, we have fat tissue. Name of this fat is corpus adiposum orbita. And this fat separates from eyeball with the help of fascia, that is vagina bulbi, or Tenon's capsule, that is fascia which is separate eyeball from fat tissue.
So this muscle is superior,
yes,
and this one inferior, superior, or this one is levator palpebrae?
Palpebrae, no, I think that is both of them. Just a moment. It is superior oblique muscle, that is tendon of superior oblique muscle. And why it is it? Okay, I check what is this. Why it is two heads? Maybe you're right. Maybe it is levator palpebrae, but it's not attached to eyeball. It's attached to superior eyelid. Yes. What else? Lacrimal apparate. Lacrimal apparate consists of lacrimal gland, and ducts of lacrimal gland, ductus lacrimalis, opens into superior fornix of conjunctiva. If we closed our eyes between eyeball and eyelids, it is superior, inferior eyelid, it is eyelashes, it is conjunctiva, superior fornix, inferior fornix, and between eyelids and eyeball, it is space between eyelids. If we closed eyelids between them and eyeball, that is lacrimal river, rivus lacrimalis. And tears from lacrimal river goes to medial angle of eye into lacrimal lake, and from lacrimal lake superior and inferior canaliculi lacrimalis goes to lacrimal sac, and from lacrimal sac continues into ductus nasolacrimalis, which opens into inferior nasal meatus. That all of these structures together, that is lacrimal apparate. What else? Visual analyzer. That is right and left eyeball. In eyeball, first neuron, and that is receptor. It is rods and cones. That is first neuron, and they are photoreceptors. Second neuron, that is bipolar neuron. Today you already answer. And the third neuron in retina, that is ganglionic cell. An axons of ganglionic cell makes an optic nerve. An optic nerve passes through optic canal and continues to optic chiasma. And I think you know that only medial fibers goes to opposite side in optic chiasma, medial fiber, from middle part of retina. From here and from here, from middle sides. From lateral part of retina, fibers goes to the same side in at the same optic tract, cleities. That is why if tumor of a hypophysis of pituitary gland and it pressed to optic chiasma, in this case, these medial fibers cannot conduct impulses from medial part of retina, and medial part of retina receive stimuli from peripheral area of vision. That is why if you have tumor of hypophysis, you will see like in tube. You can see everything what is in front from you, but peripheral area of vision impossible to see. Cleities. And optic tract goes to subcortical visual centers. They are superior colliculus of midbrain, the same lateral geniculate body, and posterior nuclei of thalamus. From lateral geniculate body and posterior nuclei of thalamus through posterior crus of internal capsule goes to cortical center in occipital lobe, near of sulcus calcarinus. Yes, in both sides from sulcus calcarinus. Yes, you're right. And from nuclei in superior colliculus, tractus tecta spinalis continues to spinal cord, and this tract goes to motor nuclei and continues to striatic muscles. That is protection from strong visual stimuli. Tractus tecta spinalis, and some fibers goes to nucleus accessorius, that is autonomic nucleus of oculomotor nerve, third cranial nerve, and from this nerve preganglionic fibers goes to ciliary ganglion, and nervi ciliaris brevis continues to musculus sphincter pupillae. If you was in dark room and then switch on the light, in this case through wide pupil, a lot of light goes to retina. It's stimuli of rods and cones, bipolar ganglionic cells, and impulses goes to nucleus accessorius. This nucleus sends impulses to ciliary ganglion, and nervi ciliaris brevis supplies musculus sphincter pupillae, and pupil constrict in this case. That is pupil reflex. This diagram is present in your manual except first, second, and third neuron, but I recommend you to draw together with photoreceptors, bipolar, and ganglionic, like in my diagram. And all another structures, they are present in your manual. This diagram and accessory organs of eye next time.